So this is an attempt to explain electron configuration and show it to you. So the electron configuration is the distribution of electrons, and electrons will distribute into different sublevels, F, P, D, and F. The S sublevel will hold 2 electrons, the P will hold 6, the D will hold 10, the F will hold 14. And you also need to know that there are different energy levels which these sublevels will fill into. And those go from 1 to 7, you can kind of see here. And they go across on the periodic table. And so, to start, we will try to do lithium. Well, we won't try, we will do it. We will do, not lithium, sorry. Actually, no, we're not going to do lithium because I found lithium is a bad example, because it only has 3 electrons and it doesn't show what I need you to know. So we will do nitrogen instead. Nitrogen has 7 electrons, I can tell by looking at the atomic number, which would be this number. We'll use lithium as the example for the atomic number. So nitrogen has 7 electrons, so to write it out as this, we have 1s, 2s, 2p, 3p, 3s, 3p, 4s, 3d, and so on and so forth. You can see that. And this will go on higher and higher. I'm not going to go there though, for the sake of time. And so to write it out, you're going to use little half arrows. You're going to use half arrows to draw it out. And the reason being, or before we do that, actually I don't know why we use little half arrows, so sorry, I can't help you there. But the little half arrows will face one way and then the opposite way. Reason being is because electrons have different spin. One electron will spin clockwise, the other will spin counterclockwise. So to write out nitrogen, has 7 electrons, we will fill the 1s, then the 2s, we've used 4 electrons, we still have 3 to go. We will fill in the 2p. The reason we didn't fill it in like we did the S is because they're different spots. It's like a bus. You don't sit next to somebody when there's an open seat, so these electrons don't pair up because they're still open seats. If we were to do oxygen, which has 8, we would then put another electron right there, and then so on and so forth. To write out electron configuration completely the way you would normally do it, for nitrogen, we would write that, and then we'd go 1s, 2, this 2, you can't really see it, but the 2 is there because 1s has 2 electrons. Then we'll do 2s2, it also has 2 electrons. Assuming we're still doing nitrogen and this electron doesn't exist, we will do 2p3 because there's only 3 electrons. So, there's also the noble gas notation, which is when you would write the noble gas right before this atom, or element, sorry. So the noble gas before nitrogen would be helium. So what we would do to write it out, we put He in brackets, and then to finish it off, we would go to the next highest energy level, or not energy level, but orbital, which would be 2s2, and then we'd finish with 2p3. The reason being that we write it out this way, this would actually be the correct way to write it out if you were doing a large atom, or a large element, sorry. You would write it out like this to save room on the paper, whatever you're writing on. For another element that we will do is silver. I've got a flashcard. So silver has 47 electrons. To write it out, we will pretend these aren't written there. So we got 1 electron, 2 electron, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, my mistake, 14, 15, 16, 17, 18, 19, 20, 21, 22. I messed up again. I can't believe it. I messed up again. Again and again. 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47. So you can see why, after doing silver, you don't write it out this way, but you would rather write it out one of these ways. And then even for larger elements, you wouldn't want to write it out that way because that's forever long. And I will show you that. So the abbreviation for silver is AG. We'll do 1s2, 2s2, 2p6, 3s2, and then 4d9 for the 9 electrons, obviously. And after writing that out, you can see why we don't want to write it that way. It's long. So to do the noble gas notation for silver, we're going to use krypton because it's the element that comes before silver over here. So what we do, again, we write it in brackets, krypton, and then to do it, we're going to write, what? We will write, hold on, my pencil got caught. We will write 5s2, because that is the next orbital that was filled, and then 4d9. And that's you see why you would want to write out the noble gas notation, because it's much shorter than doing it this way or this way. And one thing I failed to mention earlier is that the reason the P would have 3, the S would have 1 of these little dashes, and the F would have 7 is because they hold 2 electrons per little dash. So for the P to hold 6, you have 3 dashes. You get the point. Let's see. Okay, so now another important thing to know is where these S, P, D, and F orbitals, sublevels, are on the periodic table. So I already wrote them down on a previous attempt. So these over here are the S level, and then the S also includes helium over here. The P sublevels, orbitals, are over here in this quadrant. We'll go down. And then the D over here, this block, and then the F over here, F, right here. This is the F block. And so you can see why the 1s1 would only be 1s, or hydrogen would only be 1s1. Reason being it has 1 electron, and it's in the 1s section of the periodic table. So 1s1, and then helium is 1s2, because while it's on here on a normal periodic table, really it would be over here in this area, so it's 1s2, and then down here this would be 2s1, and then 2s2, 3s1, 3s2, 4s1, 4s2, you get the point, so on and so forth. And it also is important to know that the p orbitals will start at 2, not 1 like the s would, and then the d will start at 3, and then the f will start at 4. So you kind of see a little pattern. You got s starts at 1, p starts at 2, d starts at 3, f starts at 4. The way it's written on this paper, 1, 2, 3, 4, you can kind of get the point, a little pattern. Okay, so now we need to discuss the energy levels. And so, if you look here on this, actually, I'm going to bring this over here. If you look over here, you got the 1, 2, 3, 4, 5, 6, and 7. Those are energy levels, 1 through 7. There are 7 energy levels throughout all the elements that these will all fall into. Elements on this row up here would fall into the first energy level. That down here in the second, they would fall in the second. You get so on and so forth. And so now we're going to show where these energy levels are. So if you look here on my bigger periodic table, you guys probably can't really see that. But if you look here, you got 1s, and then 1s2, 1s1, and then 1s2. And those are going to be their own, 1s is in its own energy level. And electrons will fill into the lowest energy level, and then they will move on and up. And this is a higher energy level than down here. That's also important to know. And then if you look over here in this 2s, you got the 2s1, 2s2, and then 2p over here. And so you see there are 2 sublevels in this energy level. So we would draw the line right here. The same thing also with the 3s and the 3p. So this would be the next energy level. So far we have 1, 2, 3 energy levels. And then down here, where the energy levels get a little bigger, we've got the 4s1, the 3d, and the 4p. So what this energy level would look like, it would start here, and then it would go all the way to the 4p. And then it would go so on and so forth, and however many number, or the sublevel in each row would represent how many of these. So, for example, there are 3 in the 4s1 and the 3d, and then the 4p. There are 3 there, so we have 4s, 3d, 4p, and those make up one sublevel, or one energy level.